Hello ladies and gentlemen, and welcome to the next part of this episode. This is the last slide from the previous part, just to remind you where we got to. All the nuclear structures that you've seen over the last few videos have been built using these rules and the building blocks that we've just mentioned here. Although we've not shown you all of these different nuclear structures, we are able to produce them all. Also, from these we're able to explain quantum mechanical spin, which relates to the orientation of the nuclei in question. However, we will be doing a video on this later. Furthermore, we've found patterns relating to a particular type of structure and their radioactive half-life. For example, a column of boxes with a neutron hat attached to it becomes more stable the taller the column. For example, carbon-15, a column of 3 boxes with a neutron hat, has a half-life of 2.5 seconds, whereas calcium-43, a column of 10 boxes with a neutron hat, is stable. Again, we will be doing an explicit video discussing all of these correlations between the different structures and their half-lives. Lastly in this list of examples, although as mentioned in the first video, this theory does cover much more than what we've mentioned here, is the fact that we can produce all of the nuclear structures within a radioactive decay tree. Thus, we are able to see exactly what the nucleus looks like at each step. Talking of radioactive decay trees, here is a complete tree of all of the isotopes that result in nitrogen-14. So for example, if we were to take carbon-19, which is the top left-hand diagram, then we can see that it will eject one of the neutrons from its hat, whilst one of the other neutrons beta decays. If you look closely, we have put a little beta minus symbol on the top back neutron. Now in reality, any one of the neutrons within the hat arrangement could be ejected. We've just pushed one of them from the side neutrons out to firstly show you that the neutron will be ejected, and secondly the two neutrons that are left already make a hat arrangement, thus making it easier for you to see what is happening. Anyway, this decay of carbon-19 produces nitrogen-18, which then beta decays and emits an alpha to produce carbon-14. Lastly, carbon-14 beta decays to produce nitrogen-14. A similar thing happens with all the other branches within the tree, and as you can see, they all eventually produce the exact same version of nitrogen-14. Therefore, overall in this video we've shown you all of the major building blocks that make up all the nuclei of all of the isotopes of all of the elements. We've spoken about neutron bonds and the fact that they should always be paired together for the best stability, that neighbouring columns need to be turned by 90 degrees to increase distance between the protons and thus increase the stability. Lastly, we've discussed the degree of oddness of a nuclear structure. In particular, we mentioned that structures with 2 or more degrees of oddness are highly unstable and are likely to blow themselves apart. In our last video in this group, giving you an overview of this proposition, we will be looking at the electron structure and the order the electrons fill these structures. In particular, we will be explaining why the natural electron filling pattern does not always follow Mandelung's rule. So I hope that you will actually join us for that video. But if you'd like to know more information in the meantime, then please do visit our website at www.bowder-limited.co.uk and or see other videos. Lastly, please note that this proposition has not yet been accepted, so don't use it to answer exam questions. However, we would like to hear your views, opinions and questions regarding it, so thank you for watching.